Hi, everyone. So, welcome to week 6 of our C workshop. Today, we'll be talking about call by reference and bubble sort for arrays. If you have any questions, just put them in the chat and May will get to them. So, we have a lesson handout that you guys could access through the website, and you can also access this presentation. It would be amazing if you guys could go and open it right now and just give us a thumbs up when everyone's gotten to it. Okay, so we're just gonna quickly go over last week's homework. On the left, you have the first project, which was to initialize an array of size 5 and fill it with the numbers 1, 3, 5, 7, and 9. And you were supposed to write a code that goes through or traverses through the array while using a while loop and display each part of the array. And then you're supposed to do this with a do while loop and a for loop. So there's all three examples here. The do while's first, the while loop second, and the for loop is last. On the right, there was a second project in which you were supposed to allow the user to enter numbers into the array, and the code should have allowed you to input 10 values or stopped if you entered the number 25 and then displayed all of the values. And you were allowed to use any of the three loops. Here they have the while and if loops, and then the while on the last. Yeah. Okay. So today we're going to be talking about call by value, call by reference, and bubble sort. Here we have an example of the call by value. In this code, a call by value is when you search the array for a specific value. In this code, we have a while loop, and it's conditional, which means the three conditions have to be true. The first one, as you can see, is found must be 0. The second is you can't exceed the number of spots, which is 31, or like 31 boxes of the array. And the third is there must be a value in the array box that you're looking at. Inside of there is the if loop. The if loop compares the number inside the array box and the number that you're trying to find. And if that number is found, it exits the while loop and enters into the second if else. If the number is not found, you move on to another box and repeat the while loop. Once you exit the while loop in whichever format, either the conditions aren't met or you found the number you were looking for, you go into the if else. You would print out the number is not on the list if you can't find the number and found is still 0. Or if found is 1 and you found the number, and you would tell the user where the number was and the address it was located at. So the second example is about call by reference. And call by reference is when it's indirectly changing the array, which is different from call by value, because call by value directly changes the array. Call by reference is like the game telephone. In telephone, you don't go to the last person and you tell them the sentence. It goes through a group of people who talk and gets through the last person. Yeah. So the same way, call by reference is when a function doesn't make a copy of the array, but rather says what's going to change, and the change occurs automatically into the original array. Here we have an example about temperature input. It asks the user to input different temperatures in Fahrenheit, then uses a separate function to convert them from Fahrenheit to Celsius. But as you can see, in the separate function, it's not making a copy of the original array, it's doing a call by reference, so that any changes made in the separate function are made to the original array. So for an example, well, in this one, the separate function allows us to change the values from Fahrenheit to Celsius by multiplying by 5/9 and subtracting 32. However, if I was to do the same exact example, but increase the temperature by 1, and I did this in a separate function, so if I add 1 in the separate function and print out all the temperatures, all of them would be increased by 1, even though the changes were made in a different function. We'll talk more about functions and pointers next week. Okay, now we're going to talk about bubble sort. So a metaphor to understand bubble sort is pretend you threw a rock into a pond. As the rock sinks, the air bubbles trapped under it will float towards the top of the pond, one by one. In bubble sort, the largest numbers will sink to the end of the array, like the rock sinking to the bottom of the pond, and the smaller numbers would float towards the front of the array, like the bubbles to the surface of the pond. The rocks will sink faster than the bubbles will float, so the larger number will get to the end faster than the smaller numbers would get to the front. The end result would be an array of numbers arranged from least to greatest. The bubble sort does this by comparing two numbers and switching them if they're in the wrong order. So here we can see 6 and 1. 6 is obviously greater, and then it goes on to the next box, 6 and 4. Since 6 is greater, it keeps on going 6 and 3, 6 and 2, 6 and 5, and finally 6 is at the end. Here, the larger numbers move faster than the smaller numbers to their right spot. So for 4, 4 is able to get to the front much faster than 2 is able to get next to 1. So yeah. As you can see, the process is long and very time consuming. This could make your program's runtime longer. Bubble sort is efficient when the numbers aren't too mixed up or are near sorted. So here we're on the third pass. And finally, we have only the number 3 to sort out. And it's much faster. There's less things that you have to compare. And this is why it's easier if the numbers are already nearly sorted. Okay, for the syntax for bubble sort. So the first for loop determines the possible number of passes. In the last example, only 3 passes were needed. For 6 numbers, there are 5 possible passes. It's usually the number of numbers minus 1. The second for loop traverses through the array to make sure that the number does not surpass the number of spaces you have in your array. The if loop determines if 2 numbers need to be swapped. If you don't have the swap variable, you will overwrite the other variables. This means you will lose one of the values. For example, if you just did example subscript n equals example subscript n plus 1, and example subscript n plus 1 equals example subscript n, then both variables would hold the same value because the original value is overwritten. So whatever was in example subscript n would now be an example subscript n plus 1. And for example, if example subscript n had the number 2, and example subscript n plus 1 had the number 4, they would both now be the number 2. So the other loops that we use is the for loop, which displays each number in the output by traversing through the array and displaying each number individually. The printf is outside the for loop, so there isn't a line between every number. You can use a while loop to display the numbers in the array. For review, there were 2 for loops and an if loop. The code inside an if loop only happens if the condition is true. If the condition is not true, the code inside the loop will not be run. For loops will continue to happen until the condition is proven false. For loops are used when you want to do something a specific number of times. You have to make sure that could you possibly type up what part you need explained again, or just all of the syntax? Okay, so the first for loop determines the possible number of passes. And in the last example, we only needed 3 passes. However, it usually happens that the number of numbers you have minus 1 is the number of passes you need. So if we had 6, it would be 5 number of passes if the entire array was like completely jumbled up. The second for loop, which is the n equals 1, n less than 5, and n plus plus, allows for the code to traverse through the array, making sure that the number doesn't surpass the number of spaces you have in your array. So it's not that you if you have 10 different places or 10 different boxes in your array, you don't accidentally go into 11, or you don't only go to 9 and don't hit the 10th one. The if loop determines if the two numbers need to be swapped, so it's a conditional. And then here we talk about a swap variable. If they do need to be swapped, you need to have a swap variable. So the reason we have this is so that the number we're trying to swap and the number that was originally in the box don't get mixed up. So say example subscript n was 2. We now put that in swap and then have example subscript n equal to example subscript n plus 1, which could be 4. Which would be 1. And then you would switch those. So example subscript n would be 1. And then example subscript n plus 1 would be swap, which was originally 2. Yeah. The third for loop is to display each number in the output by traversing through the array and displaying each number individually. The printf is outside the for loop so that there aren't any spaces between every number. And yeah, so you can do this entire thing using a while loop to display the numbers in the array. But that's the only other variation we could find. So for review, there are 2 for loops and 1 if loop. The code inside an if loop only happens if the condition is true. If the condition is not true, the code inside the loop will never be run. So if example subscript n is less than example subscript n plus 1, you don't even have to do the switch. None of the swap happens, and you just keep on going. Here's the link to access the homework. There's 2 different projects plus the handout that you had, and you can turn it in at the website. Another way to access the homework is through the website, and you can email us if you have any questions, and just make sure to turn in the homework by Saturday. Yeah. Any questions? Yeah, if not, you guys are free to try the homework and ask us questions for the remaining time. If not, you guys could leave the call.